please go ahead and go live. Thank you. Okay, so people joining this live stream, sorry, we're starting a bit late. We are looking at machine learning for Wolfram Language version 13. And we had already started on this, hadn't we?
Yes, so the new names you see up there: image content detect, text content detect, content detector function.
Okay. And we see these as being somewhat interim names, yes?
Well, there was a point that Shadi was making to me in the chat that we use, I mean, the first two could be interim until we have a final free-form content detection that can work on multiple
on just a content
types.
detect.
Exactly. The point that Shadi was making was between content detect and content detection. I don't want to open the discussion again. That the main thing was that we typically call detection with the noun the function that generates
exactly
the object.
The object, yes.
Like dimension reduction, feature extraction versus feature extract, dimension.
Yeah,
reduce.
this is wrong. This is wrong. We should, if it's called detect, it should be able to have. This is just wrong. I mean, if there's an image there, if you can say image content detect, and then you've got a picture of a piece of fruit, comma these things here, that is a correctly named detect function.
Like classify, for example, that
Yes.
has 2-argument form. Yeah, my only concern with that is that I'm not sure we want to encourage the use of a 2-argument form
because so it's so slow.
Yes, and even in future, I mean, I don't know. Like, I don't have a super strong opinion. I tend to think that in the general use, the
will it always be so slow? Are you sure we can't make it faster? I mean,
no, we will. I think we will but it's not going to come immediately. So, and
how
when it will,
how slow is it?
I think that you need at least half an hour to get some results, and probably 2-3 hours to get the proper thing. This is in general a slow thing. Like these fine tunings can take, like a full training can take weeks, and this fine tuning can take one day if you want to do.
Okay, so this is not an interactive.
So let's change the name.
Yeah, it's the wrong name. We're signing up for something we can't deliver.
Yeah.
Right. I mean, so if I take this, you're saying, okay, let me see what happens here. I don't understand. I told it a time goal of 1 minute.
It's the time goal is basically the like try to stop as soon as you can after 1 minute, and for some stuff it's not really possible to go as low as 1 minute. So if you say like 5 minutes, it will probably manage to.
What is this?
No, this is a transient. There's a bug that we know is not affecting the result.
Okay, so so this is a very serious training thing.
Yeah. I mean, the big advantage of this is that it's automating a whole lot of things that you don't need to know. You don't need to know how to build.
Let me make a suggestion. Given how complicated this is, maybe we should call it image content or content detect train or something like that. Have the word train in there. Because net train, everybody understands that net training is a complicated process. You know, because most of our functions that are just blah, 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 detect or whatever, you know, this should have the word training in there.
So,
I mean, it would usually be because
where would you want to?
I don't know.
We can't just
becoming very big. Yes.
Yeah,
if we add training to that, this is.
I know. So let's think about this. Well, at least the description should be train an image content detector.
Yes, I agree with that.
Isn't it like that already?
Oh, let's look.
Or no?
Yeah, you're right.
But the name should probably be detection in that, you know, from that previous.
Yeah, it's crazy to.
Yeah.
Hold on, but I'm still thinking. Hold on a second. Okay, we've got a content detector function as the output, right?
Mm-hmm. that we envision to stay as a name.
Yeah. What the heck is the right way to do this in terms of parts of speech for train image content detector? I mean, look, this is way too slow to be anything other than a training. I mean, it might even be the slowest function in the system, other than nettrain, perhaps. The slowest function, in terms of its minimal use, it might be the slowest basic example in our examples. Is that a likely thing to be the case?
That could be.
Okay.
It's still saving you days if you don't want to start from scratch.
No, it's wonderful. It's wonderful. I just want to make sure people understand how wonderful it is, rather than just being annoyed at how slow it is.
It makes sense. It makes sense.
Okay, let me just see what would happen if we had, oh my gosh, this is frozen. Wow, what's going on? Why is this, something is really happening?
By the way, if you abort during the training, you got the result out. It's just not fully trained.
Okay, hold on. Let me just do something here. Why is this spinning like this? There's some bug in this. Oh, great. Come on. Something is very wrong here with this version. Somebody
I marked it.
I mean, you can use the training image is not proper, but you're not likely to get.
I want to see something really work here. I'm not happy with that.
Web image search.
Yeah, I'm doing something here. I've got an apple.
Was it from your desk?
No.
Well, I'm surprised.
That what? That it worked?
Yes. It was not nearly enough. I mean, you trained this on 3 images.
I know.
So it has some augmentation going on inside, of course. That's
well, otherwise it wouldn't be.
Yeah, this is probably too small. You can do a certain threshold, a very low number, and see if it was actually getting hints at that.
So why can't I tell this thing? Like, I'm really sure there's one of those things. I mean, can I tell it? Surely it makes a difference whether it's like, I'm really sure there's an apple, an orange, or a banana in this picture. Now just tell me which one. Versus free form, is it, is there anything like this in there?
I mean, it's something that you can build using this function. Yeah.
No, but I'm asking the question, why not? Wouldn't it be when you tell that function?
I'm not sure. I'm not sure. One of the big problems here is the localization. Like you still needs a lot of information, a lot of training to find objects.
By the way, is that there's no possibility of a training panel that shows losses going down and so on?
Yeah, sure. I plan to, like, if you do $debug mode true, which is a bit hacky at the moment, you can enable a lot more reporting. And one thing I'm planning is to, if we can have a double panel, like we can have a the NetTrain panel explicitly shown.
I have to say, I favor the name Train Image Content Detector. I know it's long and ponderous, but it says what it does. And by the time you've got this amount of time necessary to do it, I just don't think it's right to pretend, because otherwise then somebody, when they see anomaly detection or feature extraction, they're going to think, oh my gosh, that's going to take 7 hours as well.
Yeah, no, I understand the point. Yes. And hopefully we can go back to just content detection when we have a much faster way to do fine tuning.
That's what I think we should do. Train image content detector, train text content detector.
Okay.
Sounds good.
All right. Let me just look at Marco on live stream is content detector train. Yeah, the problem with that is we have to say image content detector train. I think it's better to just say train. I think this is such a, this is, I mean, as I say, as the function with the longest.
It needs a long name because it's a long function.
Yeah, well, right. Progress reporting, does that work yet? The progress reporting thing?
Yeah, there should be true false. If you say false, it doesn't do it.
I see. Okay.
So.
Okay, well, great. All right, should we go on here? I think.
Yeah. Please.
Okay, what was next for us to look at?
So this UMap is nice. I think you might you want to be aware of this because it's a new dimension reduction method. That means that it can be used to make different visual space plot. We have a documentation page for the method, and
that's nice. But I mean, will it be used by default or not?
We are actually aiming for that. It produces more cluster data on average. So it's compared to Disney or Disney, I don't know how to pronounce that. It clusters a bit more, and for many features can be faster. Like Jerome is working hard on making this as optimal as possible, and it's already as fast as, if not faster than Disney.
Okay, so I can say feature space plot of that method arrow UMap. Is that correct?
It was working on 2 days ago. I tried this on today and it was failing. Let's hope that in your works.
By the way, for feature space plot, please do make sure. I mean, these particular things, like here, these are graphics and they have to be rasterized and so on. And for some reason, there's something that's happening very, very slowly.
Well, rasterize is slow in general.
Yeah.
It's
okay. Anyway.
I'm working. I've been working to make rasterize faster for like 3 years. So the kernel side of it is in general.
So do you think that's different from the TSNE result?
It should be. If you look at the documentation page, it's on our example data sets. It's very clear. You can use. I don't know if Jerome did it in Visual Space Plot, but the dimension reduce has the UMap link. Dimension reduction actually is a main function.
There are method options here.
Yeah, if you scroll down, there should be. Yeah, there it is. Future UMap. So, for example, if you click on.
So do these all have separate documentation pages?
Yeah.
You know what? I think that we should put a thing up here saying.
Yeah. No. Absolutely. I started doing some knitting for neural networks. I didn't have time to do machine learning, but there are a lot of these that we need.
Okay, fine. But I think we should put it up there, and we should have a guide page which includes like these pictures, or some version of these, some idealized version of these pictures.
Yep.
Because that's what I want to pick from.
Yeah. No. It makes total sense. It makes total sense. And actually, when we do webinars, we basically build a grid with those pictures. So.
Right. By the way, I hope that we have fixed
and why isn't that in the page itself, the reference page itself? Why don't we have a visual picker if that's what you want to use to pick method from?
Yeah, why not? Right there with the methods.
Yeah, exactly. A 3-column.
Oh yeah, absolutely. Yeah. We're doing that in many other cases. So
exactly,
good idea.
Okay, so question for this. There have been some issues with feature space plot about when it actually plots the points versus the images, etc. Has that been fixed or not yet?
We opened a bunch of bugs. We are basically only provided the algorithmical backend for this. I had some talks with Brett to do a round of updates. We should probably do another one. I know that some stuff was
because
fixed.
it's kind of non-functional. So can you push that? And if I need to get involved, I will.
No, I don't think it will be needed. I mean, we are, some stuff is being tracked, sometimes it's being fixed already. So.
Okay. So decision tree is as a tree expression. Cool.
Yeah. We look
Can I
at this.
see
We look
that?
at this last time. Is we are adding this. I don't think we want to document this round because we are not super happy about the fact that we discussed this last time. Yeah, like the decision tree is splitting on pre-processed data. And actually, Roger forwarded me some emails with users that agree with me and think that is still useful because you can train. We can have examples where you train trees with minimal pre-processing. But in general, we want a more global approach where you can always have a decision tree train on the side of the classifier that can explain it, basically. So it's kind of a pre-step for that.
Mm-hmm.
I don't think I have some notebooks, but I don't think I have anything shareable right now. So I would, if we go ahead, I will look for it and I can send you an example.
Okay. Randomness. That's very good. That's very good. That's an important thing.
This was a pain. Is still a pain. Is not completely solved because there's some stuff that is completely ingrained in the framework, and we have only limited a lot of time for refactoring, but it's already much better than before. And it was a much requested feature by internal, external people, customers, to have it always reproducible.
Mm-hmm.
Yeah, there's some internal change of libraries,
Okay.
not
All right.
not a big thing.
Oh, that's good. Unified Playlist Framework. Okay, net encoder. Save definitions. What's that for?
We use. I mean, by default, we use it to manipulate or stuff like that to embed to serialize the definition of functions in cells, so you don't have to have a kernel running where you, or actually you don't have to have a definition running when you run the manipulate. This has a similar problem.
Wait a minute. What manipulate? I don't understand.
So if you run a manipulate where you say like I don't know x equal 5 and you plot between 0 and x, and then you close and you reopen a notebook with a new kernel.
Sure, I understand what save definition does in general, but what's the relationship?
Okay. In this case, the point is that you could have net encoder function, comma f, and if you don't have f, like the version before, it was telling you, oh, this relies on some external definition. So you had to use explicit functions like function.
Oh, I see. Blah, blah, I understand. So it's the same. The point is, this is analogous to manipulate, that net encoder has a dependence on an external function, and you're making sure that the actual net encoder symbolic expression contains the definition of that function.
Exactly.
Okay.
This way, you can add it to a network, save it in a network file, and when you import it, you will have it. You don't need to pass around definitions.
Wait, what is this net? I mean, net graph, adding new ports to an existing graph at any level.
Oh, we did a complete revamp on the port syntax. It was like some stuff you couldn't do before.
Wait a minute. Now, have we reviewed that?
What? Net unfold?
The port syntax.
Oh no, sorry. The port syntax is the same. It's just that some stuff used that, for example, you couldn't connect like a nested container inside to some other container in some other place. You had to be always at the same top level. Now it's a lot more flexible.
Right. I mean,
so
all this stuff, I have to say, is, eventually, this is kind of, I mean, well, I don't know. This is block diagrams versus code, basically. I mean, we've got.
I know. We had this discussion many times. The end game is not going to be this one. I agree with you.
Yeah.
But for the time being, let's make it as pleasant as possible to
I agree.
It's already pretty nice to work with other graphs.
That's great. Yeah, it's great. Join chains with single input or single output graphs. Okay, fine. That's a big deal, isn't it? Supporting automatic differentiation in compiled layer.
Yeah, now it's being enabled by default, so you don't need to provide separately the forward and backward pass. You can only provide forward pass, and if we can differentiate it, we will do that. Otherwise,
So
we'll
what's a
tell
good
you.
example of that? Let me just see. second. I just have to realize something. Okay. So let me just see how this works. Oh boy. So this is really using the compiler.
Yeah. Also using the compiler to do the automated differentiation.
So this is not a simple end user type thing. This is pretty serious stuff.
No, this is if you want to write your own, if you have a compile function and you want to use it to train a network.
So you're saying that all functions that are compilable are also differentiable. Is that a true statement?
No. We have an automatic differentiation engine in the compiler that can fail. So,
Almost.
So for example, if I have a Bessel function in the compiler, can I differentiate it?
Yes, but I don't think we do have it in the compiler.
Okay, but a sine function we do. And
Yes,
we can differentiate
yes.
Yeah.
More interestingly, array functions, linear
Right.
algebra functions.
Like fold. Is fold differentiable?
Don't know, but in principle it should be, because that's just
there's
a loop.
fold list here, which I think
Yeah.
is more obviously differentiable than fold.
Yeah, I don't know. I think it should be, because it's just a loop. And loops are differentiable for sure.
Right. Okay.
Anyway, this I have to say, has been a very nice interaction with the compiler team. I think it was good for both that we moved ahead with this one.
Who has been the main? What is the main axis of interaction there?
Rob Knapp.
Okay.
Yeah, I mean, Rob is the one that's done the automatic differentiation there.
Okay.
And we're going to bring it out more broadly, but not
cool.
We couldn't make it for this release, but
I wonder whether automatic differentiation has uses outside of machine learning.
Of course it does. It came up with optimization, and it's used in optimization, and in machine learning it's used for optimization.
Yeah, but even beyond that, I mean, if we could take a symbolic expression and differentiate it, a program and differentiate it.
Yes.
Interesting concept. I mean, I'm wondering what else, there must be sensitivity analysis for numerical precision and things like that we could do with that.
Yes. Most sensitive, yes, true. We can do that just for a program. But if you think of a solver, the way we compute sensitivity is usually done a little bit differently. Actually, we do use, now that I think about it, we do use automatic differentiation for some of that.
I would think so. We use symbolic differentiation on actual expressions, I would think.
No. Well, it's a complicated story. It would be better if Rob is here, actually.
Okay. All right. Fine.
Okay.
X new models. What is X?
Well,
like
at the time we wrote this, we didn't know what X was going to be.
Okay,
it's going to be like around 5, 6.
Okay.
Yeah.
Cool.
For video.
Cool.
Yeah.
And right now, I mean, the neural net repository seems to be just working well. There's, it's just like, it's a good medium. We put things in it and it just works, right?
Yeah, it is. I mean, we are smoothing out a lot of things, and is actually a good testing ground for our Onyx import-export.
Yes. Okay, good.
And it keeps us focused on the kind of modern architectures and stuff. So,
all right, let's talk about text translation. So this is now a built-in text translation. Is that what you're telling me?
No, it's not there yet. This is there was a note here. I mean, the point is that we have a function ready. I need to talk to Christian to integrate this in text translation. You're not going to find it in the prototype. The reason is that it requires serious work on the resource system to handle massive models. And it just recently got merged. Like recently, I mean,
okay.
like this.
All right, but the goal here is to have text translation be something that does not require any API access.
Exactly. I mean, our API, I guess. With we have
but any external API access. This
exactly.
is something that will happen in product on people's computers, etc. Right?
Yeah. Yeah, and actually we have, you had the idea when we first brought it up, and this is on track, as I don't think has been merged yet in the resource framework, but has been worked on, to have asynchronous download of resources. So the end game could be that you run text translation on a string, it sends that to the cloud, and it starts downloading the network. So until the network is there, you can have limited access using the cloud, like, at low rate.
Yeah,
And then you have it locally, and that's much faster, and you can do whatever you want.
that's good. That's a good idea. It sounds like it was my idea. So whatever.
I told you, it was your idea.
Yeah, right.
I'm not
Okay.
claiming it was mine.
Right. By the way, here's a question. Our speech recognize, does it work in languages other than English?
No.
I think that we could, in principle, I mean, I think that there are other, like Chinese, for instance.
What about
But
Spanish?
Don't know. I think it was very limited in other. Chinese for sure.
Oh, has been trained on Chinese as well, our speech recognizer, or you are saying that we have data?
The underlying, I think it's.
I think we should have a look. Given that we're now having local text translation, we should have a look at you know, what's possible with speech recognize for other languages.
Right.
Okay, well, good stuff. Perkinj, our live stream asks about Wolfram language documentation for time complexity. Most of our functions, it's way too complicated to say. The place where that is well documented is in, look at all this lovely stuff. And in fact, I want to look at this documentation right now myself. In data structures, is this going to have the trees in it? Here, there's the time complexity. For stuff like this, for these very well-defined lower level things, we absolutely have time complexity estimates. But for something like text translation, it's meaningless, way too complicated. All right, anything else we should cover in this meeting?
I think that's it.
Okay, excellent.
There was a lot of work that went into getting MXNet to a new,
I'm sure,
form, so that
and that now works on the Apple native silicon stuff.
Yeah, we have a native build for that.
Good.
Oh, one thing we can quickly look at. I don't know if you care about. Like, there was you opened the documentation page for net unfold. This is a new symbol that we want to add. Okay.
But it doesn't. It has no sense of. This is the inverse. Is it in fact the inverse of fold?
Is the inverse of the net fold operator. Is not strictly speaking the inverse of a fold function.
Right.
It sort of picks out the you see that core there? It's like the F. The F.
Yeah, like you have fold F, and this takes out the F. Except that it's not as clear in many networks. Yeah, it isn't like in fold F.
Right. Well, so I mean, the analogy would be, if I take
this one has more like a systems definition. See, it has an F and a G. There's an output equation too. See, I mean, you could have that sort of. You could just have a more complicated sort of F, and you can have an output. But normally you separate the two. If you see that below the picture.
Yeah.
Equation, the state update, and then there's the output equation, the G.
Right. I mean, here we would normally say differences to get. I mean, if F was plus, the unfold of this would be differences.
But you want F as a net. You want F as an operator.
I know. I'm trying to understand. Is there a look, you see there?
Yeah.
I mean, that's getting back the data, but the whole point is what you're doing here is, you know, what is to fold to foldless with plus. Differences is the unfolder of foldless with plus. The question is there a general unfolder for foldless with Fs?
I don't think so. But
no, I don't think there is either, because I think that's a special thing for neural net. Like, that is a way of munging the F to get you.
Yeah.
Yeah, I understand what this is doing. It makes
But
sense.
you don't even look at the data. Like you would
I
look at
know.
your fold list plus as a symbolic folder, and you
Yeah, I
say how
understand.
can I get it out? And this is very useful for many NLP applications because you want to use that F to generate text sequences mainly.
Sounds good. All right, we should wrap it up here. And
Yeah.
I don't know. I think Roger, I think you're involved in the multi-computation language design at the top of the next hour, right?
I didn't. It's not on my calendar.
Oh no, really?
Well,
that's crazy. You should be in that.
okay.
It's at the top of the next hour. I'll
Have someone send me a calendar, and I'll be there. Or send me some place to go. I can go there.
Right, and where? Yeah. They know they'll do it. Okay, well, good stuff. Very nice. Well, good work, and until the next time.